what is the need of these horizontal and vertical sync pulses? Vertical sync pulses are for frame oscillator and horizontal sync pulses are for the horizontal oscillator. These pulses are to synchronize these oscillators. Horizontal pulse frequency is 15,625 hertz. Pulse width is of 4.8 microsecond and it is counted as a high frequency. What about the vertical sync pulse? The frequency of vertical sync pulse is 50 hertz. Pulse width is of 160 microsecond and it is known as a low frequency signal. So, there is a big difference between horizontal and vertical frequencies in terms of pulse width. Therefore, to separate these pulses, we have to dependent on their frequency and not on their amplitude. To separate horizontal and vertical sync pulses from each other, we need the RC filter. Let us see here in this diagram. If we see here, this is the sync separator stage, which get the CCBS, means color composite video signal. After automatic biasings, this separated sync is available at collector of this transistor, and shape of this separated sync is this one, which has both horizontal and vertical sync pulses. H means horizontal sync, E means equalizing pulses, and these vertical sync pulses in serrated form. I have already told you that the horizontal oscillator and vertical oscillator may not accept the separated sync as such. Then what you have to do? By integrating the composite sync, we get this vertical sync in this form. If the separated sync is differentiated, we get horizontal sync pulse of this shape. A RC filter, what is this RC filter? A low pass filter to separate the vertical pulses, and high pass filter to separate the horizontal pulses. The differentiated pulses are meant for horizontal stage and the integrated pulses are meant for the vertical stage. What is the condition? The condition is the value of resistance and capacitance, means the time constant. Time constant RC should be 1/2 to 1/3 or less compared to the horizontal sync. For example, if we have taken the resistance of 2 kilo ohm and the capacitance of 50 picofarad, Let us calculate the time constant, whether it will differentiate the horizontal sink or not. The condition has already been given. The time constant should be 1 by 2 to 1 by 3 of the horizontal sink pulse width. The time constant comes out to be 0.1 microsecond. It means it is the time which is lying 1 by 2 to 1 by 3 microsecond, and it will differentiate the horizontal sink. How to differentiate? This is the circuit of differentiator. It has a capacitance and a resistance and a pulse which has one portion of short duration and another portion of the longer duration enters in the differentiator circuit, and the output pulse is of this shape. You say, why it is so? It is totally different compared to the input pulse. This was the shape of separated sink. Therefore, after passing the separated sink as such through the differentiator, the output pulse is of this shape. What are the conditions for differentiation? When the capacitor fully charged, what it will do? The capacitor will not react for DC value, it will react only to the changing value, means the AC signal. Therefore, once the capacitor has been charged, if there is no variation, it will start discharging, and discharging comes to the opposite direction, means it forms the another pulse, but different direction. At the lagging edge of this pulse, if here the voltage drops suddenly and another pulse is of short duration is formed, the time is opposite direction discharging the capacitor. Let us see here the differentiation. Whatever I have told here, let us see again in this figure. This is differentiator and these two pulses are entering in differentiator. This capacitor of the lower value and charges immediately when a long duration pulse come, or even the pulse of shorter duration, but higher than the 0.1 microsecond, the capacitor will charge, and when this non changing position, means the DC portion comes, what this capacitor will do? This capacitor will start discharging, and in discharging, the negative side of the capacitor sends the negative pulse and a peak is formed. Let us see here in this figure, any pulse which is entering in this differentiator circuit, these capacitance and resistance, they differentiate and the differentiated pulse is available at the output. If you see again here, as soon as this pulse enters in the differentiator circuit, the output pulse is available immediately at the output, means there is no time delay, because here there is no active device, and the action is so fast that differentiated pulses are available continuously, and these pulses are meant for horizontal oscillator. Let us see these resistance and capacitance, whether they will differentiate the pulse or not, means what is their time constant. We have taken a resistance of 2 kilo ohm and a capacitance of 50 picofarad. If you calculate, the time constant is 0.1 microsecond and duration of 0.1 microsecond is certainly lower than the 4.8 microsecond the horizontal pulse width. Therefore, it will differentiate the pulse. So, this is the condition for differentiation, and your time constant is meeting the requirement. So, this conclusion is meant for whether the RC filter meant for differentiation will differentiate the pulse or not. So, it is differentiating. So, now come to the integrator part, and this integrator part is meant for vertical sink. It has the long time constant, the capacitor will fully charge and will discharge slowly, and we have already told you the capacitor will not react with DC values, it will react only the AC values, and it will also not react to the fast changing pulses, means of higher frequencies. This is another condition. So, it can be used as a noise gate also. This is the circuit diagram of a integrator. The resistance and the capacitance form the RC filter. Here the two pulses, pulse 1 which is of shorter duration, but of the same amplitude as that of the pulse number 2 which is of longer duration, but same amplitude, enters this integrator. The pulse which is of short duration develops the pulse of less amplitude, and the pulse which is of longer duration develops the amplitude of higher value. It means a short duration pulse and means the high duration pulse, the output is totally different, which was not in case of differentiator, but it is in case of integrator. What are the conditions for integrator? The output at the integrator will depend upon the duration of pulse width and not merely on the amplitude. Therefore, short duration pulses can be eliminated, or any pulse which is of higher frequency, means short duration, as a noise can be eliminated here. Integrator we have already explained. Let us see the functioning of this integrator. The pulse will enter in the input, and after integration the pulse will be available at the output of integrator. Watch the movement. As soon as this pulse enter at the integrator, at the same time the integrated pulse is available at output. See the fast movement, pulses are entering and immediately they are available at the output, because there is a no delay. It is also clear the short duration pulses are making less amplitude compared to the long duration pulses. So, this was about the integrator and the differentiator. We have already told you the functioning of integrator depends upon the pulse duration and not on merely amplitude. So, these were the conclusion about the differentiator and integrators. What are the troubles in television for synchronization purpose? When we talk about the synchronization, synchronization means horizontal and vertical both. If there is a trouble in composite sync, it will affect horizontal and vertical both. No sync, picture will be unstable on the TV screen, and this is one of the example where the combined sync is missing, and we get the picture on TV screen of this type, where horizontal and vertical both are missing and picture is rolling horizontal and vertically both. If only vertical pulse is missing, picture will start rolling vertically, it will be unstable. In the similar way, the horizontal synchronization is affected by the horizontal sync pulse for phase and frequency both. Here this trouble is for the horizontal phase. Horizontal phase out means the picture is shifted to one side. If the frequency is out, the picture starts horizontal rolling. This is the effect of out of horizontal frequency. The noise pulses, if they enter inside a TV, certainly they will destabilize the horizontal and vertical oscillator. If horizontal and vertical oscillator slips from its original frequency, they will affect the picture formation on the TV screen. See in the figure, a momentary noise figure or noise pulse which is higher compared to the sync pulse. We have been discussing the sync pulse separation is dependent on the amplitude, and as soon as this sync pulse reaches to sync pulse separator, they are separated. Since the noise pulse amplitude more than sync pulse, it will also be separated, and if it is separated, it will go to horizontal and vertical oscillator and will affect the functioning of horizontal and vertical oscillator. As soon as this sync along with the noise enters, both the oscillator will lose its frequency stabilization, and losing the frequency stabilization means a problem in picture synchronization, and will not get the picture or will get the picture which is unstable in the form. Here the sync pulse along with the noise is entering and making effect up to this period. This period is a period which makes the TV unstable for picture synchronization. So, we have to find out some way how to eliminate this noise. So, we have to make some arrangement of the noise gate which can cancel the noise pulse. Fortunately, this noise gate is available on the video ICs meant for sync separation and horizontal and vertical oscillator. If you see this figure, the noise gate is here and sync separator is here. They feed the inverted pulse to sync separator to reduce the noise level, and we get the horizontal and vertical sync free from the noise pulses. So, this was one of the circuit taken from the television. So, you have seen about the picture synchronization, the stages, the effect and the processes. In the end, I thank you.